Hi, I'm Mr. Franklin, and today we're going to be talking about free body diagrams. Now, we've already talked about adding vectors, and basically free body diagrams are going to be our way of drawing force vectors and then adding them up together by a picture. So while it's very similar, it's helpful to review, but let's put it in context of force. So let's say I have a car, okay, it's sitting on the ground and it's not moving. What are the forces acting on this car? So we might say the force due to gravity. Now, where is this force of gravity actually acting on this car? Well, as we're going to discover as we talk more about gravity, the force of gravity is acting on anything that has mass. So any piece of this car, every little atom, every little proton, every little neutron, every little piece of the car that has mass is experiencing a force due to gravity. Now, as you can see, that can get quite complex to think about and talk about. But what we like to do in physics is we try to keep things simple. We try to define things via simplicity. And if I take and do calculus, I can actually take all of these forces and I can basically show them and represent them as a single arrow. The force due to gravity, which we would say is the weight of the car. What's another force acting on this car sitting on the road? So we could have the road pushing back on the car. So where the tires meet the road, we have the road pushing up against the weight. So we have the weight of the car pushing on the road, and then we have the road pushing back. So we could actually draw a vector for, this is what, 1, 2, 3, 1, 2. So keep them the same size because they're the same magnitude. So this is the force of the road on the car. Now, if I were to take these two vectors like we learned in our previous unit and were to add them together, I could take one. So I'm going to take the gravity arrow, which is 1, 2, 3 boxes long, 1, 2, 3 boxes long. And then I'm going to take my orange arrow and I'm going to lift it. I'm going to lift it and I'm going to put it down, and I'm going to take the tail of it here and I'm going to put it on the tip of my other arrow. And when I do that, what you will see, sorry, these aren't exactly straight, but what you'll see is force of gravity pulls me down, but then the force of the road pushes me back up, and I'm back where I started. And if I were to add these together, if I were to do the sum of the forces, the total is going to be 0. Now this symbol right here means sum. It is the Greek letter sigma. It's the capital letter, sigma, and it means sum. What does the math word sum mean? It means addition. So after we add all of the forces together, we get a force equal to 0. If the sum of the forces equals 0, then the acceleration of this object is also equal to 0. If the car is not accelerating, then the car follows the first law. If it's at rest, it stays at rest. Okay. If it were in motion, it would stay in motion. Let's take a look at another situation. So let's take a look at a couple of these. We're going to skip over this and we'll come back to those. So same story. We have our car sitting on the road, but this time it's going from a stoplight. It turns green, and so my car has a positive acceleration. So now let's draw the forces. Let's do a free body diagram. So put a dot to represent the car, and what are my forces? So once again, we have the force of gravity acting on it. I have the force of the road pushing back, and those will cancel out. But it's accelerating, so if it's accelerating, it must have a force of some kind that's pushing it. So I have the force due to, and on a free body diagram, you want to label these. So force of gravity, force of the road, and the force of a push. Now, the gotcha is, are there any other, we got to ask that question, are there any other forces acting on the car? Now, we might think of there's friction, there's air resistance, there's all these other forces. And those are good questions to ask. But unless a problem tells you that exists specifically, we're going to assume that there's no friction. Okay? So this is all we have for our forces. Now we like that because look at that picture. If I look at the forces here, force of the road, force of the push, force of gravity, which way is the car going to move? Okay, it's going to move to the right, which is what our original picture is showing us. And because the force, we could do our sum of the forces, draw our diagram, and draw our acceleration, then pick up the force of the road, tail to tip. Those cancel out, but then I can go tail to tip with the third vector, and my result is what? It's going that way, which is what we've already seen. Okay? So the sum of the forces equals the force of the push, which means we have an acceleration that is positive in the direction of push. Okay? Let's take a look at the same instance, same situation, except now we do have friction. And let's say that we don't have an acceleration, but we have a velocity. So what I'm saying is, we have the force of gravity, force of the road, those cancel out, so there's no up or down motion. We have a force of a push, but then I also have a force of wind resistance and the road all added together, and all of the forces are balanced out. Now what you might think, just by looking at that, all we can tell from that picture is that the sum of the forces equals 0 and that our acceleration equals 0. Just with this picture alone, we can't tell if it's moving or if it's stationary. But in our word problem, we said it was already moving at 20 meters per second. And since there is no acceleration, then my speed will continue to remain 20 meters per second. So an object in motion will stay in motion unless acted on by an outside force. Okay, so let's take a look at this more mathematically. If I have two forces pushing to the right, I can add those forces. Okay. And the total will be 3 plus 4, which equals 7 newtons. So the sum of the forces. Okay? Let's look at this next one. I have 4 newtons to the right, negative 3 to the left, with a result of positive 1. So 4 newtons plus negative 3 newtons equals 1 newton. And you know what? I really shouldn't leave the units off of these guys up here. Okay? So that's how you do those.